This is Calculus 2 class. Today we are starting our work with a sequence. A sequence is simply an ordered list of numbers, but it can be represented in the different ways. Sometimes with a formula, sometimes by describing how each term is generated from previous one. By end of these lectures, you will be able to recognize how to write the sequence in both explicit and recursive forms. Second, you also look at two most important common type of sequence, arithmetic and geometric sequence, and learn how to find the formulas for the nth term. Then we'll go deeper into describing character of sequence. We'll talk about when a sequence is decreasing and increasing, when it's considered monotonic, then how to tell if it is bounded sequence. Let's get started. What is a sequence? Very simple way. This is list of number. So before we talking about example of a sequence, let's just start with the notation. A1, A2, A3, an, B1, B2, B3, bn. That's the general form of sequence. A1 we call first term, A2 we're gonna say second term, A3 we're gonna say third term, an we're gonna say nth term. Another way to write the sequence is set notation n start 1 to infinity. So that's the right sequence. So simply we write set notation an, we assume n start 1. Let's have first example of a sequence. I give set notation of a sequence. They don't talk about where n is start. Then we assume n start to 1. So an gonna be 1 over 2n, we're gonna start n equal 1. I want to write the three terms of a sequence means n equal 1, that's the start point. You're gonna plug in n equal 1 in the sequence. That's gonna be a1 equal 1 over 2, 1's power. That's gonna be 1 over 2. That's the first term. Second term, n equal 2, a2, and replace with 2, 1 over 2 square, 2 square is 1/4. N equals 3, that's the third term, a3. You plug in n equals 3, that's gonna be 1 over 8. That's the first example of sequence. Let's have second example of sequence. Very careful here. -1 and n's power times n, 2 to the n start to 1 to infinity. This time they specifically say n start to 1. Sometimes they start to 2. Okay guys, sometimes they start to 0. So an gonna be this time -1 and n over 2 to the n. Let's find the first three terms. Start n equal 1, guys, n equal 1. You plug in n equal 1 here, 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 here. So a1 gonna be -1 to 1 power times 1, 2 to the 1. -1, 1's power is -1. -1, 1 is -1 over 2. Now let's go to n equal 2. You plug in the 2 in n. So that's gonna be a2, -1 square times 2 over 2 square. 2 square is 4. -1 square is 1 times 2 is 2. You can simplify, you don't have to. Next one is n equal 3. Now n gonna be 3 replaced with 3. A3 gonna be negative 1 cube times 3 over 2 cube. Negative 1 cube is negative 1 times 3, negative 3. Bottom gonna be 8. We call this one. Can you notice something, guys? They change the sign. First term is negative, second term positive, third term is negative, fourth term is positive. They change the sign, alternate the sign. We call alternating sequence. This is a recursive sequence. A recursive sequence is one whether each term is defined in terms of a previous term or terms instead of by a single expressive formula. The Fibonacci sequence is one of the most recursive sequences. Let's find each term of Fibonacci sequence. F1 is 1, guys. F2 is 1. Fn equal Fn minus 1 plus Fn minus 2. So n is start with 3. Let's just start n is 3. N equals 3. You plug in the here. N equals 3. N is 3. N minus 1 is 2. N minus 2 is 1. So F3 gonna be F2 plus F1. F2 is 1, F1 is 1, 1 plus 1 is 2. F3 is sum of F2 plus F1. Let's go first term. M4, F4, F3 plus F2. Sum of previous two terms. F2 is 1, F3 is 2. They add together 3. Let's try one more. Next term. N equal 5, f over 5 equal f4 plus f3. That's gonna be 3 plus 2, 5. So we have Fibonacci sequence looks like this. First term, second, third term is 2, fourth term is 1 plus 2 is 3, fifth term is gonna be 2 plus 3, 5, 8 gonna be 6 term is 3 plus 5, keep going. So Fibonacci numbers are especially interesting because they appear in many natural patterns like spire in the shells and sunflowers. Previous example, guys, we find each term from the first term to the third term. Now, I give list of number. You're gonna find the general term. Sequence is pattern. They have rules. So you guys have to find the pattern or rule. Look at this A1. This sequence is A1 is 1. A2 gonna be 1 over 3. I put the 3 ones power just in case you guys see the pattern. A3 gonna be 1 over 9. 3 cube, right? 9 is 3 cube. I'm trying to find the pattern, guys. A4 gonna be 1 over 27. So I find the power of 3 cube, guys. So I try to figure it out. A1, rewrite it. A1 is 1 over 3 to 0 power. 3 to 0 power is 1. So can you see the pattern? A1 is 1 over 3, 0. A2 gonna be 1 over 3, 1's power. A3 gonna be 1 over 3 cube. Square, guys. I'm sorry. A3 is 1 over 3 square. A4 is 1 over 3 cube. Can you find the pattern? 1, this power is 0, 2 power is 1, 3's power is 2, 4's power is 3. So you guys find AN gonna be 1 over, decreasing by 1. Here is N, 3n minus 1. That's the general term of this sequence. So you have to find the pattern or rule or formula for the given sequence. Let's have another example. Take a look at the list of number. So first, we have put the A1 is 1.5, A2 gonna be negative 2 over 3, A3 gonna be 3 and 4, A4 gonna be negative 4 over 5. Compared to previous example, that's the sign is alternating. Can you see that? Sign gonna be positive, negative, positive, negative. That case, we have find the sign term. So AN equal, here is top, you have put the sign term. First one is positive, second is negative, third is positive. I put the negative 1 and minus 1 and equal 1. 1 minus 1 is 0, negative 1, 0 is 1. And equal 2, 2 minus 1 is 1, negative 1. 1's power is negative 1. There is not unique way write this sign term, but this is general way write the sign term right there, guys, okay? So second part is we have find the numerator. So what is the numerator each term? First one is gonna be 1, 2, 3, 4, right? So we have numerator 1, 2, 3, 4. So first one is 1, second is 2, third is 3, fourth is 4. So numerator gonna be n. Now we are looking for a denominator. 2, 3, 4, 5. So A1 denominator gonna be 2, A2 denominator 3, A3 denominator 4, A4 denominator 5, AN gonna be n plus 1. You find general term of sequence AN right there, guys. This is alternating series. You have to find the sign term this form, okay? Let's have specific sequence. There are two specific sequence. First one is arithmetic sequence. I explain arithmetic sequence with example. Look at this list of number. Can you find some pattern? So what kind of pattern they have? Guys, look at this first one is, what did you do? How can make 10 to the 15? That you have add 5, guys. How about 15 and 20? You add 5. 25 and 20 to 25, that you add 5. Each time, previous term to the next, you add 5. We call that difference. That's gonna be D. D gonna be 5. Then number might negative, okay? But same number, you're gonna add and subtract. That's called D. Also, that's the arithmetic sequence, okay? Now, we're gonna find the general term of arithmetic sequence. Let's start with A1. A1 is 10. A2 gonna be 15, right? So I can get the 15. 10 plus 5. So 10 is A1, 5 gonna be D. How about A3? A3 gonna be 20. 15 plus 5. 15 is A2 plus A2 plus D. So A2 is what? A1 plus D. So A1 plus D plus D. So A1 plus D gonna be A1 plus 2D. Can you guess? A1 is A1, A2 gonna be A1 plus D, A3 gonna be A1 plus 2D. I think you can guess. A4 gonna be A1 plus 3D. So let's check it. A1 is 10, 3 times 5. That's gonna be 25. You got the right there, guys. Now, how about AN? General term of arithmetic sequence gonna be AN gonna be A1 plus n minus F1D. That's you find the general term of arithmetic sequence. Now this time, I'm gonna introduce geometric sequence. Let's have example first. Here it is. 4, 8, 16, 32. 4, 8, 16, 32. What kind of pattern they have? 4 times, what is 8? 2. 8 times, what is 16? Next term, 2. 6 times, what is 32? 2, right? We call every single time previous to next, you multiply by 2. So we call that the ratio, R equal 2, okay? So A1 is 4, A2 is 8, 4 times 2 is 8. So A1 is 4, R is 2. That's why A1 times R. A3 is 16. How can I get the 16, guys? 8 times 2, that's the 16. A2 times R. What is A2? A1 times R times R. A1 times R times R. How many R? A1 R square. Same pattern, guys. A1 is 4. A2 is A1 times R. A3 gonna be A1 times R square. So A4 gonna be A1 times R cube. A1 is 4, R is 2. That make what? 32? Right, that's make 32 right there, guys. So what is the general term of geometric sequence gonna be? A1, R. N is nth term, n minus 1. Can you see the pattern? 3's power is 2, 4's power is 3. This is the general term of geometric sequence. So we study sequence, we also learn how to find the general term when we have arithmetic sequence, when you have geometric sequence. Now, let's visualize the sequence. So sketch the sequence. Guys, you sketch the function. That way, sketch the sequence. You like function. Treat like a function, but n is natural number. X-axis represent n value. Y-axis represent an. So this is a sequence. First one is, guys, look at this. First one is A1. That's the n equal 1. A1, y value is 1 over 2. That's you're going to plot it, okay? So that's the first A1, first term. This represents A1. What is A2? That's going to be A2. Second term, 2 over 3. Here is 2. 2 is, n is 2. This one is A2, y value. That point represents 2A2. N equals 3. 3 over 4. This one is n equals 3. Then you find the point here. N equals 3. That point A3, y value. That point represent A equal A3. So that's how to sketch all the sequence. Here is a dot because n equal natural number. So we're gonna analyze graph of sequence, guys. First one is we wanna have monotonic sequence. So it looks like increasing, decreasing function. So let's see the left one. See the pattern of sequence, guys. Sequence is n equal 1, n equal 2, n equal 3, n equal 4. A1, A2, A3, A4. What happened? The sequence is, number of sequence is decreasing. We call this is a decreasing sequence. Mathematic way to define A1 greater than A2. Look at this. A1, A2, A3. A1 greater than A2, A2 greater than A3. Generally saying AN is greater than AN plus 1. In the other hand, right picture right there. 1 is A1, A2, A3, A4, A5. What happened, this pattern is increasing. We call this is increasing sequence. So that's gonna be A1 is less than A2, A3 gonna be greater than A2, AN is less than AN plus 1. So that's the increasing sequence. Sequence is decreasing, sequence increasing. We're gonna say monotonic sequence. That's the character of a sequence. Let's show that sequence is decreasing. What is mean by decreasing, guys? Decreasing mean by A1 is bigger than A2, A2 is bigger than A3, AN is bigger than AN plus 1. That's mean decreasing, okay? So, I'm gonna find A1 first. A1 gonna be 1 plus 5, 1 over 6. A2 gonna be 1 over 2 plus 5, 1 over 7. Which one is bigger, guys? 1 over 6, 1 over 7. Definitely 1 over 6 is bigger, right? So, A1 is bigger than A2. Let's check A3. A3 gonna be 1 over 3 plus 5, 1 over 8. Which one is bigger? A2 is bigger, okay? Let's check the general term. AN gonna be 1 over n plus 5. AN plus 1 is 1 over n plus 1 plus 5, n plus 6. So check the denominator. N plus 5, n plus 6. N plus 6 is bigger. You reciprocal meaning is this inequality, flip it. So AN is bigger than n plus 1. This sequence gonna be decreasing. You prove this sequence is decreasing. Now, let's show n square is increasing. What is the definition of increasing, guys? Look at this. A1 is less than A2, A2 is less than A3. That's the increasing. So let's find A1. A1 is n equal 1. 1 square is 1. A2, 2 square is 4. Which one is bigger? A2 is bigger, right, guys? A3, 3 square is 9. 4 and 9. A3 is bigger. What's the general term? AN, n square, AN plus 1, n plus 1 square. Of course, AN plus 1 is bigger. That's why this is increasing sequence, guys. We have two different types of sequence. One is increasing, the other is decreasing. We call monotonic sequence. Another characteristic of sequence is bounded. Guys, what is bounded means? So I sketched the graph of sequence. I sketched the sequence right here. So look at this one. A1 is 1. A2 gonna be 2, A3 gonna be 1, A4 gonna be 2, right? So which meaning is A sequence gonna be 1, 2, 1, 2, 1, 2, 1, 2. So I can write AN general sequence between the 1 and 2. So this one is low bound, 2 is upper bound. That case, all the value of a sequence between the 1 and 2, we call this sequence is bounded, okay? On the other hand, look at this sequence. A1 is 1, 2, A2 is here, A3 is here, 4 is A4, but sequence is increasing, keep increasing. We call this sequence is unbounded. Simply say we cannot find low limit, upper limit. We cannot find it. That case, we're gonna say unbounded. Look at this example, okay? Determine if the sequence are bounded. I give 1 over n. Let's figure it out. So plug in the n equal 1. First term is gonna be 1. Second term is 1 over 2. Third term is 1 over 3. Fourth term is 1 over 4. What is low bound? Low limit? What is upper limit? 1 over n. an is, where is an, guys? An is, all an is greater than 0. You find the low limit. What is upper limit? All the sequence is less than 1. We call this sequence is bounded. Okay? But the other hand, n, a1 is 1, a2 is 2, a3 is 3, a4 is 4, a5 is 5. You can say an is always greater or equal to 1, but we cannot find upper limit. So we call this is unbounded. So sequence have that character, bounded, unbounded. Another way say, you put the sequence, find the low limit, upper limit, that is bounded. You cannot find the one over limit, that's the unbounded. Let's wrap up today's lecture, guys. Sequence is an orderly list of numbers. We can describe it either with an explicit formula or recursive formula. So some special sequence like arithmetic and geometric sequence come with formulas that make it easy to find any term. We also talk about characteristic of a sequence, okay? A sequence is monotonic if it is always go to one direction, either increasing or decreasing. And the sequence is bounded, meaning is all terms stay within certain limit, never going above, never go below set values. If that is, we call bounded.